Good day, everyone, and once again we're back together. And apologies if there's a little bit of a background noise. I'll try the best that I can to speak over it. We're still continuing on that November 2022 exam. So if you haven't subscribed, please just make sure you just hit that subscribe button. And where have you been? Hey? So we'll be continuing on question 2 on this November exam. Right. So in this case, it says crate P of mass 1.2 kilograms is connected to another crate, which is Q, of mass 2 kilograms by light inextensible string. The two crates are placed on a rough horizontal surface. A constant force F of magnitude 7.5 newtons acting at an angle of theta to the horizontal is applied on the crate as shown in the diagram below. Right, now very importantly, they tell us that the crate accelerates at 0.1 meters per second squared to the right. So that's very important because then it tells us also the direction for frictional force, right? So now let's have a look at this. They say crate P experiences a constant frictional force of 1.8 newtons, right? Very important. And Q experiences a constant frictional force of 2.2 newtons. Right, so the first question they say to us, state Newton's law of motion in words. Please remember, ladies and gents, if a resultant force acts on the body will accelerate in the direction of the resultant force, and that acceleration is directly proportional to the force and inversely proportional to the mass. Guys, I've done some shorts on this to help you understand. I've even ridden on a crate just to help you guys try and memorize this better. Okay, so please use those shorts for being able to memorize these in a better way. Right. So they say to us, draw a labeled diagram for crate P. Now, I want us to note in this case, now, for crate P, what we do have are the following forces. We know that the string exerts a force that will, obviously cause this thing to move forward. So I'll say that tension of the string. If you say force of the string, nothing wrong with that. So this is the force of the string. Okay, but we also do have frictional force. We know friction opposes motion, right? So in this case, that would be the friction force. Okay, and of course we do have gravitational force, which acts vertically downwards. So that's the force of gravity. Nothing wrong if you decide to call it the weight. Okay, please, and when you label the diagram, label fully, right? And we've got the normal force. I can see this. I'm trying to draw it perpendicular. So in this case, that is what the normal force would look like. Okay, I'm really trying my best here. Right, there we go. So we've got the normal force over there, right? So these are the forces that are acting. And by the way, ladies and gents, the mark allocation for the free body diagram will always kind of indicate to you, what the number of forces that are actually on the diagram. You can see we've got 4 forces here. So in this case, it does tell you on the right track. Okay, right. Now for 2.3.1, they say calculate the magnitude of the tension in the string. So I want to try and use this, body P in this case, to try and calculate that tension, right? So now what are we looking at? We're looking at the forces that are horizontal. So we know F net is equals to MA, but that's the sum of forces that are in the horizontal dimension in this case, which is equal to MA. Now, which forces are those? It's both the tension as well as the frictional force, right? So in this case, that's going to be the tension plus. Now, by the way, I'm going to take the direction of motion as positive. You'd help yourself in doing so, right? We always assume that the direction of motion is positive. They told us that this guy is moving to the right. So tension plus a negative frictional force. So this is the friction on P, right? Call it kinetic friction. This is equal to MA. Now let's substitute what we know. They told us that the frictional force in this case was 1.8 newtons. Sorry, that's 1.8, which is the mass on crate P is 1.25. And remember, because they are accelerating, right, it would accelerate at 0.1 as well. So this would be 1.25 multiplied by 0.1. As I did say, I'm in a bit of a noisy area, so please don't be alarmed if you hearing some sounds in the background. Right, so of course we're going to take this to the other side, right? I'm going to do that. So that's 1.25 multiplied by 0.1, okay? And in this case, we add 1.8 to that, and that gives us 1.925. You know, for the sake of accuracy, ladies and gents, of course you can say 1.93 newtons. In this case, that is what you would get for that. Okay, right. So let's go on to the next question, right? Now they want us to calculate the angle theta. So obviously now we're going to be looking at crate Q, and I want you to please note that we've got an applied force there. They didn't say we should draw the free body diagram, but I always, you know, consider it to be good practice to do so. We know we've got gravitational force over there. We've got the normal force over there, okay? We've got friction, but we also have the tension on the string, right? So we've got the tension on the string. I would imagine that the tension would probably be bigger than the tension, the friction, right? So there's our free body diagram. Now, the only issue, ladies and gents, is that when I draw this free body diagram, in this case, you'll notice that we've got a force that is neither horizontal nor vertical. It's actually acting at an angle, right? So what do? We always reduce that force into components, right? Its components, the vertical components, right? And the horizontal components. So this is the horizontal component of F, horizontal, and it also would have a vertical component, right? So in this case, we know that there's a force in the vertical dimension that is an equivalent in the vertical of the original applied force, right? So essentially, in essence, what it means is that we can actually get rid of this guy here, right? And rather replace it with its components. So what I'm going to do is take that vertical component and actually attach it to our center of gravity. The dot there actually represents the center of gravity, right? So there's our F vertical there. So I've replaced that that force with both the horizontal and the vertical components of it, right? Now, let's have a quick look at it. How do I find the horizontal component? In this case, it means that it would be the original force F multiplied by the cos of the angle theta. Now remember, force F was here, right? So the angle is here. So this would be, if we took it as a 90-degree triangle, so this would be the adjacent side, that would be the opposite side. So in this case, this is the adjacent over the hypotenuse, which is our original force, right? So we're trying to reduce that original force into, in this case, the components of it, right? So I'm going to take F net, okay, which is equal to MA. We're taking the sum of forces in the horizontal dimension, right? Now, because I've reduced that force into a horizontal force, it means I can now use it, right? So it would be the force F, the applied force, but I'm taking the horizontal dimension of it, right? minus the frictional force on Q, right? And subtract the tension which we just found. Okay? So this is going to be F, the cos of the angle theta, minus the friction. They told us that the frictional force is 2.2 for Q, right? So that's 2.2, and we subtract 1.925, and the mass of Q, I believe, is 2 kilograms, and the acceleration is 0.1. So that's 2 times 0.1. And just to keep in mind that force F is actually 7.5. Okay, so let's try and find the angle theta. Right, so 7.5 cos theta. I'm going to take everything to the other side. That becomes positive. So I will have 2 times 0.1, right, plus 2.2 plus 1.925. Okay, I get 4.325. Okay, and in this case, all I'm going to do is divide both sides by 7.5. Okay, and that means that to find the angle, in this case, I'm going to just simply say the arc cos of 4.325 over 7.5. Okay, so shift the cosine of 4.325 divided by 7.5. Okay, so I get 54.78. Okay, you can get something close to that depending on how you round it off. So the angle theta is 54.78, and that's how the cookie crumbles, ladies and gents. I hope you understood that, right? Please don't forget to subscribe and like and share, right? And of course, I'll always make sure that I give you the best of what we have to learn for both grade 12 and grade 11, and of course I'm still going to go to grade 10 as well. All right, ladies and gents, I'll see you again next time. All right, from your favorite uncle, Shap Shap.